Okay, so for project 5, questions 6 and 7 in part D, I want you to run the Wireshark application on the backtrack VM, which is the penultimate host on the path from the source to the destination host, and want to capture the packets as they are transferred. So if you're not familiar with how to use Wireshark, this video might be useful. So I have opened two VMs here. I'm going to illustrate this with just two VMs, an Ubuntu VM and a backtrack VM, and of course I'm already in the graphical interface of the backtrack VM. So open a terminal by clicking on this icon and just say Wireshark now. That's what I'm going to do. So I am going to type Wireshark and press enter. So that opens up the Wireshark packet capturing software, the application. So this is a network analyzer, so you can basically capture packets with this on the underlying Ethernet interface. So this is the interface that we are going to capture packets, whatever is sent on this interface, or sent or received on this interface. So we have not yet sent or received anything, so let me now go back to the VMs. So I have here my receiver Java program, so I'm going to use this VM, the backtrack VM, as a receiver. So I already typed my receiver, datagram receiver Java program, the one I have it in the project description. And in my Ubuntu VM, I'm going to run my sender program. So I already ran, type my sender program here. So of course you can come out and now compile the two Java programs. Okay, and make sure you find the IP address of the VM. So if I type ifconfig, that gives me the IP address of this Ubuntu VM as well as the MAC address and everything else you may need, but just knowing the IP address should be good enough. Now let me type the receiver program here and type ifconfig to know this VM's IP address, which is this. So I'm going to just first show, without running the Wireshark, to just show the connectivity between the machines. So as I showed in the said in the project description, make sure all your VMs are running with the NAT option for the network adapter. And how do you make sure that? Go to the player menu here and click on Manage Virtual Machine Settings and go to the network adapter. It should be on the NAT option. So if it is in the bridged option or something, put it on the NAT option. So all machines have a kind of IP address that comes from the same prefix. So this is, for example, is 159.133 and my Ubuntu is 159.135. So they are on the same kind of subnet or prefix, and they are directly reachable from each other. Okay. All right. So make sure you have that. You should have this if you set everything to run on the NAT option, AT option in the virtual machine settings when you install each of those virtual machines. So don't worry about it if you already have everything in the same prefix 159 or what other prefix you see for your VMs. Okay, you can also test the connectivity by doing a ping command, which you should have done in some other phase of your project. Say for example, if I want to test this, whether this VM is reachable to this VM, I can say 192.168.159.133, which is the IP address of this VM. So I get messages from the other VM. So ping here for Linux systems runs infinitely, so just press Ctrl+C to stop it. And I can also test here 192.168. Of course it should be reachable from each other. My num lock is not on, sorry. 192.168.159.135. so sorry, ping. So it should be reachable. Alright, so now let's run first our two socket programs and see if I can send and receive messages. So this is my receiver. So I already compiled my receiver, and my receiver is going to just take one command line argument, which is the port number I want to run this on. So let me run it on, say, something like 4, 5, 6, 7. So this is running. And so now let's send from this machine Java datagram sender. The first argument is the machine name, which is going to be here my IP address of the receiver. So that is 133, this machine. This machine's IP address. And the second argument is going to be the port number in which the receiver is running, and the third argument is going to be the message I want to send. So I'm going to use hello world as the message. Press enter. So it sent packet is a local print statement, and so here let me see if the message has come. Yes, so the message has come. Okay, so let me make sure. So this is my IP address and MAC address. So we'll use this to verify what we see in the packet capturing window. All right. So you can open another terminal and run your Java program, but I'm just going to run on the same terminal. Okay. So first, let's start my receiver. So I started it now. And let me start my packet capturing thing. Wireshark, it's already running. So now click on this ETH. Only when you click on the ETH0, the capture is going to start. So click on this. It has started, but no packets are being sent or received, except there may be some local ARP broadcast for this virtual machines, as we are running two virtual machines, so they'll be trying to find each other's MAC address, so don't worry about it. So what we need actually is to start our sending machines. So let sending programs. So let me send this, and the packet has been received. So that particular packet we want to capture, right? So we see here a lot of packets already sent and received, but when you look at it, you see these are the two packets that we are really interested at. Okay, actually you could capture stop the capture by saying capture stop, so that will stop capturing. Okay, so we don't need to capture any more packets for this example, so I stop the capture, so no more packets will be captured. Now you should be able to look at the packets and see that this is sent from this IP address to this IP address, right? Because 135 was the IP address of my Ubuntu machine, and 133 is the IP address of my backtrack machine. So the source Ubuntu machine has 159.135 IP address, and the destination is 159.133 IP address. You could even filter by using IPADDR equals 192.168.159.133, and you'll see only this particular packet. Okay. You could also filter by using port numbers, udp.port, and the port number we are using is 4567, and you see this thing. As you remove this from the filter menu, you should see the other packets, but I'm not sure. Let me see. Press and enter. Yeah, so once you remove that filter, whatever you had, and press and enter, you should again see all the packets. Okay, so now if you type again udp.port 4567, press enter, you'll get only this packet, and if you want to see the other packets, just go ahead and remove this and press and enter. You should see all the packets. All right, so this is a packet we are interested at, right? So let's again use a filter, either using IP address or port number. So let's then look at more details for this packet. So you know from the class that a packet has all the MAC header, IP header, UDP header, and all these things in this case. So let's look at the MAC header, and you can pull up this thing up. So you see here the destination MAC address is this. So who is the destination? The backtrack VM. So this is its MAC address. 76E34A, it's here, and the source MAC address corresponds to our Ubuntu VM, which is this 8DEAC4 and all these things. All right. Then the IP address, as you can see, you can make it, you can expand it. So this is the Ubuntu VM's IP address, and the destination is this machine, the backtrack VM 149.133. You can then compress the options. Now this is the UDP header. As you can see, the UDP header has only 4 fields: the source port, destination port, the length, and the checksum. And the source port is the port number at which my sending app process is running. As I said in class during socket programming lectures, if you don't specify an explicit port to open the sending socket, right? I didn't specify the port to open the sending socket, so it runs on a port number assigned by the operating system, and this 39738 is the port number assigned by the operating system for the sending process in the Ubuntu VM, but the destination port number should be 4567 because you're sending to this port number. So you can see all these things. All right, and the data, you can also see what is in the data. Let me compress this. So the data should be this, and what we sent was hello world, right? So I thought you should be able to see the binary version of this too. Let me see. This should be the ASCII values of what you are sending, but I think you should be able to see somehow even at the bit level. But if not, this is hello world, right? So let's see. This is 1 2 3 4 5 6 7 8 9 10 11 characters. So that's what it is, 11 bytes. I sent 11 bytes of data, and this is, what is that? Hello world. Now let me see. 48 is this is all in hexadecimal, right? So 48 in hexadecimal. So 1 second, let me open my calculator. 8 plus 64, right? So 72 is the ASCII value of H in decimal, but 48 is ASCII value of H in hexadecimal, and 65 is the ASCII value of H in E. 6C is the ASCII value of H, L, and again 6C corresponds to the second L. Then 6F corresponds to ASCII value of this O, and 20 is the ASCII value of blank space. Again, everything is in hexadecimal. Okay, 20 is for this blank space between hello and world. 57 is for W, and again you see 6F corresponding to, again 6F here is for O. Okay, so these are the hexadecimal ASCII values that show up for each of those characters you're sending. Alright, so I think this should help you to use Wireshark. So now you can stop. I already stopped this thing, so you can again start if you want. Okay, now if you want to just close this capture file, you can click on this X. So when you click on this X, it's going to ask you whether you want to save this. You can also save this packets that you have captured to a file that can be again opened with this Wireshark application. You don't need to save it unless you want to. Okay, so you can continue without saving and just click that. You'll get back to this menu. So we are going to just click on ETH0 and launch the packet capturing window. You don't need to do anything else on this interface for your project, but feel free to explore anything else you want. Okay, so let me stop this, close this. So if I press this, it's going to terminate the Wireshark application and get back to your terminal. Okay, so email me if you have any questions. Okay, I'm available all the time during this break.